everybody, I am standing on my driveway ready to do some maths. My question for you is, how tall is the light? We could get a ladder and a big tape measure and measure it directly, but there are better ways and more efficient ways of doing it, especially when it comes to measuring very tall things that we can't actually get a ladder for. So what we need to do is measure two things first, and then we're going to use some trigonometry to work out how tall the light actually is. The first thing that we need to measure is the distance from where I'm standing to the base of the pole. The second thing that we need to measure is the angle of elevation, which if I put my arms out horizontally and point one up to the top of the pole, to the light, the angle of elevation is this angle in here. Let's imagine that I measured those earlier and I've got some dimensions. So now what we're going to do is do some calculations, including a diagram. Remember, the first step is always to draw a diagram. So Sam, just come around here so you're looking over my shoulder. Alright, so the first thing we're going to do is draw a diagram. And here's our light pole. The light is at the very top, that's what we're measuring. Here is where I was standing, and this distance here is 6 meters. The angle that we've measured here is 43.5 meters. So now I've got my diagram. The other thing that we need to take into account is the fact that my eye height, where I was measuring from, is actually 1 meter 78 off the ground. So we need to calculate this height here and then add on the ground height. So the way that we do that is we identify the ratio that we want to use. We've got this angle, we need the opposite, and we've got the adjacent, so we use tan. So tan theta equals opposite over adjacent. Then we sub in our known values and it becomes tan of 43.5 equals opposite, which we're going to call L for light, so we'll call this L, divided by adjacent, which is 6, and then we rearrange and it becomes 6 tan 43.5 equals the height of L. So on our calculator we go 6 tan 43.5, make sure you're in degrees, close brackets, and it comes out to 5.6. So L equals 5.69 meters. Now, in the context of the question, we also needed to add on the height of my eye height. So the light pole full height, whoops, hang on, I need more chalk. Equals the light plus 1.78.
What is it with that chalk?
What
is it with that chalk?
Equals 5.69 plus 1.78. And if we add that on, plus 1.78, we get 7.47. So then we write a concluding statement on the driveway, which is the light is 7.47 meters high. The end.